Welcome everyone. We are discussing combination. Today I will discuss mixed problem of permutation and combination. First we select the things, then we arrange. That is mixed problem of permutation and combination. So look, problem number 1. How many different words can be formed from 12 consonants and 5 vowels by taking 4 consonants and 3 vowels in each word? In each word. So, consonants. Vowels. 12 consonants and 5 vowels. You have to select from 12 consonants and 5 vowels. So I have already solved this type of problem. Now look, from 12 consonants you have to take 4, and from 5 vowels you have to take 3. So number of selection. 12C4 into 5C3. 12C4 into 5C3. By APC, this is 12C4, this is 5C3. Now, formation of words means arrangements of letters. We have taken 4 plus 3, that is 7 letters. Then we have to arrange it. Mind it, here what is formation of arrangements of letters with meaning or without meaning. So this is total number of selections. We have select 4 plus 3 equals to 7 letters. Now 7 letters can be arranged in factorial 7 ways. Factorial 7 ways. Therefore, number of possible words. So total selection 12C4 into 5C3. Then arrangements. This total selection is this one. Now this is a large number. So you can expand it. For problem of competition, you have to expand. So this is possible number of words. So look, this type of problem, for this type of problem, we have to select the things. So we have select 5, 4 plus 3 equals to 7 letters. So this is selections. Then you have to arrange the letters. Therefore, number of possible words equals to 12C4 into 5C3 into factorial 7. Now second one. How many words of 5 different letters, mind it, different, we are considering for different letters, can be formed taking 3 letters from the word pound and 2 letters from the word gram. So, pound. How many letters? 5. Gram. How many letters? 4. And we have to select 3 letters from pound and 2 letters from gram. So by number of selection 100% same that of earlier. So 5C3 into 4C2. Letters are different. So this is selection. So we have select 3 plus 2 equals to 5 letters. So 5 letters can be arranged in factorial 5 ways. Therefore, possible 5 letters word 4C3 5C3 into 4C2 into factorial 5. 5C3 is 10, 4C is 6, and this is 120. So 7200. These are the possible ways. So this is very simple. Next, now we consider two problems. Mixed problem of permutation and combination, but slightly different from the earlier two. So 3 and 4. First consider 4. A tea party is arranged for 16 persons along two sides of a long table with 8 chairs on each side. 4 persons wish to sit on one particular side and 2 on other side. In how many ways they can be seated? So there is a tea table. 8 chairs here. 1, 2, 3, 4, 5, 6, 7, 8. And here also 8. 1, 2, 3, 4, 5, 6, 7, 8. Now this is A side, this is B side. Now if there is no restriction, then in this side factorial 8, in this side factorial 8. But there is a restriction. 4 persons wish to sit on one particular side and 2 on other sides. So out of 16, look, out of 16 persons, 16 minus 4 plus 2 equals to 10 can sit on both sides. They have no restriction. Out of 16 persons, 10 can sit on both sides. Now, suppose here 4 persons, 4 seats already occupied. So how many seats are vacant? 4. And here how many seats are vacant? 6. So out of 10 persons, in A side, we can select 4. Because 4 seats are vacant. So out of 10 persons, 4 can select inside A in 10C4 OLs. 10C4 OLs. Out of 10, we have selected 4. So 10C4 OLs. So remaining persons, 10 minus 4 equals to 6. 10 minus 4 equals to 6. These 6% to be placed in side B. In side B. In side B, 6 persons can be selected in 6 vacant seats. In 66 ways. 66 ways. So what is total selection? Total selection equals to total selection. This is selection. 10C4 into 66. This is total selection. 10C4 into 66. Now you have to arrange 8 persons on each side. But look, there is no restriction that these 4 persons sit side by side. There is no restriction like this. So 8 persons can be arranged in side A in factorial 8 ways, and in side B they can be arranged in factorial 8 ways, because there is no restriction about arrangements. So number of arrangements equals to factorial 8 into factorial 8. Inside A, number of arrangements. Inside B, number of arrangements equals to factorial 8. So, how many ways can they be seated? Therefore, total number of possible ways. Total number of possible ways equals to 10C4 into 6C6 into factorial 8 into factorial 8. This will be total number of possible ways of their seating arrangements. Now listen, you can say we can fill up the side B at first. So look, out of 10%. So we can select in side B in 10C6 ways. Inside B, 10% can be selected in 10C6 ways. So remaining persons, what are the remaining persons? Remaining 10 minus 6 equals to 4. So inside A, they can be selected in 4C4 ways. 4 seat, 4 persons. So total selection in this case is 10C6 into 4C4. Now look, you know 10C4 equals to 10C6 and 4C4 1, 6C6 also 1. So selection is same. We can select the persons in A first or in B first, in the side B first. This is immaterial. So you can take 10C4 into 6C6 or 10C6 into 4C4 ways, because they have same result by complementary combination theorem. So this is most important problem. Now problem number 3. So exactly same problem. We are discussing it again. 100% same. In how many ways can the crew of 10-oared boat be arranged if 3 of crew can row on stroke side and 2 of them can row on boat side? So there is a boat. This is bow side, this is stroke side. Ten can be arranged if 3 of crew can row on stroke side and 2 of them can row on both side. But here it should be mentioned that number of crew in two sides are same. We are assuming it. In how many ways can the crew of 10-oared boat can be arranged if 3 of crew can row on stroke side and 2 of them can row on boat side? This is bow side, not boat. You write bow side. Bow side. Bow side. So here we assume that in stroke side and bow side, number of crew are same. So total 10. So here 5. 1, 2, 3, 4, 5. And here also 5. 1, 2, 3, 4, 5. Now it is mentioned that 3 of them can row on stroke side. So 3 places are already occupied. And here 2 can on bow side. Bow. Direction of boat. Bow side. So that of earlier, out of 10 minus 3 plus 2 equals to 5 can work in both sides. In both sides. Now in stroke side, 3 places are already filled up. So you have to fill 2. So in stroke side, 2 places, remaining 2 places can be filled by 5 crew in 5C2 ways. In 5C2 ways. Now, crew remaining equals to 5 minus 2 equals to 3. Out of 5, we have placed here 2. Now, how many gaps? 3. In both sides, remaining 3 places can be filled by 3 crew in 3C3 ways. So, total selection 5C2 into 3C3. I have already stated in previous problem you can fill up this part at the beginning. So what will be the selection? 5C3, because 3 gaps, 5 3. And remaining is 2. 5C3. Remaining is 2 and 2. This is 2C2. So 5C3 equals to 5C2. 2C2 equals to 3C3. So same. So you can write also this one. This is total number of selection. Or you can write this equals to 5C3 into 2C2 as you please. Now, number of arrangements equals to total selection. This is total selection into arrangements inside A, arrangement inside B. So this is total number of possible arrangements. So number of selection, then arrangements. So this one. This is also most important problem for competition. So through this video, I have solved 2 types of problem, mixed problem of permutation and combinations. In the next class, there will be one more class, continuation of this mixed problem of permutation and combination. So thank you for today.